Now, lastly, we will recall some derived results. Derivations you might have gone in your plus 2 level. But here, delta stands for change, S stands for entropy, H stands for enthalpy, G stands for Gibbs free energy, and E or U. So, this equation can be written as delta H, that is, this equation can be written as delta H equal to delta U plus P delta V. Instead of delta E, we can write delta U. So, E or U both mean the same. Different books or different texts follow different notation. So, delta G, delta stands for change in Gibbs free energy. So, Cp is the specific heat capacity at constant pressure, Cv specific heat capacity at constant volume or universal gas constant. As the name implies, gamma is the ratio of specific heat capacities of the same material at constant pressure and to that at constant volume. So, these relations are to be borne in mind for the thing. Here there is a suffix called delta St. It is nothing but delta S total. Total means sum of the system and surroundings. So, we have seen that universe is divided into two components, system and surrounding. So, delta S total means total change in entropy. Total change in entropy can be resolved into change in entropy for the system and change in entropy for the surroundings. So, some of these changes in it, once again, entropy is a thermodynamic property, it is a measure of disorderliness, it cannot be directly measured, only its change can be measured. So, entropy change for the system plus that for the surroundings is always positive. So, entropy change is always positive. So, that is the essence of second law. So, entropy of the universe goes on increasing. One of the statements of second law is that entropy of the universe, that is disorderliness of the universe, goes on increasing, which is the fate of the vital Kali Yuga. So, increases, goes on. Randomness, disorderliness goes on, increases, that is the essence of second law. First law, energy of the universe is constant. Second law, entropy of the universe goes on increasing. So, that is the mathematical form. If it increases means delta S is positive or delta S is greater than 0. That is one version. Second law, mathematical statement of second law, delta S equal to, for a system, change in entropy for a system is the reversible quantity of heat supplied at constant temperature. At what temperature it is supplied? By temperature at which it is supplied or removed. Already we have seen that any process takes place only at constant temperature. Boiling or melting, boiling takes place at constant temperature. So, for boiling we have to supply energy. So, the heat supplied to water to convert it to steam at 100 degree. That is called Q reversible by heat. Heat taken from steam at 100 degrees so as to be converted to water. That is meant by Q reversible by T. So, this delta S is greater than 0. Change in entropy is higher than 0 means it is in the higher or disordered state. Higher disordered state is possible only if it is energetic. Whenever we are energetic, we will not be disciplined. So, that is to be noted. Heat is absorbed by the system. Delta S is less than 0 means heat is evolved by the system, heat evolution. So, delta S is greater than 0 associated with heat absorption. Delta S, entropy change, is negative associated with heat evolution. Now, delta H is the energy content at constant pressure. Delta E or delta U is the energy content at constant volume. So, change in internal energy at constant volume and change in internal energy at constant pressure, they are related by the work done by these terms. So, the two forms are delta H equal to delta E plus P delta V or delta H equal to delta U plus P delta V. Unavailable energy is called Gibbs free energy. Unavailable energy is called gives free energy, but it is also cannot be directly measured, only the change. So delta G equal to G2 minus G1, delta H equal to H2 minus H1, but it takes place only at constant temperature. There is no T2 minus T1, but change in entropy is there, S2 minus S1. Excepting the temperature, all other thermodynamic parameters cannot be directly measured, only the changes can be measurable, that is to be noted. Here Cp of course can be measured, specific heat capacity. It is the heat requirement by the system to raise the temperature of a system from 15 degree to 16 degree for unit mass or unit quantity of the substance, that is called Cp at constant pressure. Heat requirement at constant volume is called Cv, specific capacity at constant volume. So they are related by this equation. For 1 mole of the gas, for any ideal gas, it is Cp minus Cv equal to R for ideal. All these are applicable only for gaseous systems. You have to be careful because solids or liquids cannot be compressed. There is no pressure volume changes for solids or liquids. These equations are preferably applicable for gaseous system, that to ideal gas. Ideal gas means which obey gas laws, Boyle's law, Charles law, Gay-Lussac's law. So that is given by. So the ratio of specific capacities is given by gamma. Then we have seen two types of process: isothermal process and adiabatic process. Even the processes are identified by equation. The characteristic equation for isothermal process is PV equal to constant, or you can write PV P1 V1 equal to P2 V2 at constant at a temperature, that is to be noted. Adiabatic process, PV power gamma is constant. This is not PV equal to constant. Adiabatic process, PV power gamma equal to constant, where gamma is defined as the ratio of specific heat capacities at constant pressure and constant volume. So these are the equations. If the system obeys PV equal to constant, it may undergo isothermal process. If the system obeys only PV power gamma, gamma can be more than 1 or less than 1 depending upon the type of gas, adiabatic process, which undergoes expansion, etc. so forth. Now lastly, the entropy change for different types of, we have seen about there were different types of process: isothermal, isobaric, isochoric. Isothermal means constant temperature or dT equal to 0. Isobaric means constant pressure or dP equal to 0. Isochoric means constant volume or dV equal to 0. So the change in entropy for isothermal process, already we have derived the relation for the work done. Work done by temperature is nothing but Q reversible by T. So already the same expression, the T term is divided, so it is removed from the expression. That is, so the same formula but minus. So 2.303 N log V2 by V1. Isothermal process. Temperature is constant. Expansion or compression, well, volume will change. Isobaric process means only pressure is constant. If pressure is constant, temperature may vary. That is why it is given in terms of, so constant pressure means we got to use the term Cp. 2.303 N Cp log T2 by T1. Here N is the number of moles of the gas. Cp is the specific heat capacity of the gas at constant pressure. For the same process, if it is carried out at constant volume, the expression is delta S isochoric, or change in entropy for an isochoric expansion, constant volume expansion. So that is isochoric process. It need not be expansion. So expansion means change in volume. Isochoric process, some other process which is carried out at constant volume. So this 2.303, all these processes are taking place at different temperatures, to be noted. Different temperatures. 2.303, N is the number of moles of the gas. Cv is the specific capacity of the gas at constant volume. T2 and T1 are the two different temperatures where the process takes place at different. It can be exothermic process or endothermic process, dissolution, etc. So depending upon the case, it will be varying. Lastly, the third law of thermodynamics, only the statement is to be noted for your syllabus. So, a third law states that the entropy of a pure crystalline solid at absolute zero. Capital T means, so any Kelvin temperature, lowest temperature possible is only minus 273 degrees C. Minus 2, below this temperature we cannot go. So it is called Kelvin absolute temperature, lowest achievable temperature. We cool the system. When we cool water, its temperature goes on reducing from 20, 10, 0 like that. At 0 degree it converts to ice. Still we cool, etc. going ice at minus 10, minus 20, whatever be the case. So without decomposition, if we can create low temperature, it is possible to create a temperature of only minus 273. So minus 273 degrees centigrade, or it is called 0 Kelvin. 0 Kelvin. It is the lowest achievable temperature. At the lowest achievable, this is called absolute temperature. At absolute temperature, the entropy of a pure crystalline solid is 0. Entropy is 0 means disorderliness is 0. It is having no randomness. It is highly ordered or highly perfect, as the case may be. So, highly perfect case is possible. So, even if we observe, during cooling it assumes solid state. When it assumes solid state, it will not move. If it is not moving, it is lagging liberty or lagging randomness. So that there is a total lagging of randomness only at absolute temperature. That is the qualitative statement. Mathematical form of third law of thermodynamics, limit T tends to 0 because it cannot be realized. Lowest temperature cannot be realized. That is why it tends to 0. Entropy, in all cases, entropy is once again not measurable. Only the change in entropy is measurable. That is to be noted. These are the points to be remembered, formulae and relations to be remembered for doing sums and approaching the questions. Now we can see some questions based on these relations and processes and also types of variables and properties which you have revised so far.